So let us now look uh, into the fork join parallelism. And fork join parallelism is basically that a thread can actually create children threads and wait for their completion. And when a thread creates a new thread or a process creates a new thread, you almost always have the data only shared before fork or after the join. You can, of course, share the data through a file or do something that is, well, not super I wouldn't say super intelligent, but I mean something that is weird. But in general, I mean using the thread API, the way you share data can only be before the fork, so right before you actually the new thread starts running, or right after the child thread exits, and then after the join. And there are multiple examples of this. So a web server and Apache web server actually is runs as a thread that spawns new threads for every new connection. And if you have dealt with Apache web servers before, few of you have done, I know, then what you basically have is that you can run out of connections, for example, because you have run out of threads. Because these are basically hard limits that you can set on your system because you don't want your system to be flooded with a number of threads that would kill the performance completely. There are other examples, of course, when you do merge sort in parallel. So you can do merge sort using threaded programming. And for this, please refer back to any of your data structures or algorithms, books or courses. And things such as parallel memory copy when you try to copy different chunks of memory at the same time in parallel. With this concludes today's lecture. This is the reading guide. We have actually covered chapter 3, the whole part of, except for 3.4 basically, and a large part of chapter 4 has also been covered. I will also record new videos today for the lecture. So this is the lecture that is for Tuesday. I'm sorry for the delay, but I will also record next Friday's lecture today, and also some of the Linux hands-on lectures that I started will also be recorded during today and tomorrow. I promised that there will be a lecture on architectural concepts. I have actually checked it out. I know that half of the students, are in a program which does not require architecture as as a course, basically. So you probably know less than some of the others in the course. So I will record a video with hopefully it will not be longer than 2 hours with some of the major architectural concepts when it comes to the CPU. I hope to be able to do this week. You will not everybody needs to watch that, of course. I mean, of course, it's nice to basically have refreshment on what the processor looks like and so on. But I mean, if you know this stuff, if you know what a program counter is, then just don't bother at all. But if you don't, then it would be nice to watch the video. I'm not saying that it will hurt you in any way to not watch the video. So it's not compulsory to know this beforehand, but it's kind of nice to basically know what is the difference between MIPS and, for example, and what are these different terms? RISC architecture, CISC architecture. I mean, these are very different. What are the major differences that you would expect from a different architecture and that can influence an operating system? So you can view this as the architecture video as a way to basically help you refresh your minds, but also to help you put things into context and get a hopefully better picture on how the full computer stack works. Thank you, and sorry for the delay with this lecture.